Welcome to Star Chat, the podcast where we explore the wonders of the universe and bring you the latest news from space. We are starting off with a bang, literally. A SpaceX rocket stage has crashed into the moon, leaving behind a new crater and a whole lot of interest from astronomers around the world. The impact was predicted by independent orbital analyst Bill Gray, who calculated that the 8,800-pound rocket would slam into the lunar surface near the Einstein crater at a whopping 5,400 miles per hour. The Korean Aerospace Agency's Danari lunar orbiter was in the perfect position to capture images of the impact site before and after the crash. And what they saw was pretty amazing, a dark splotch on the lunar terrain with a bright spot in the middle, suggesting that a new crater had indeed formed. NASA also planned to observe the crash site with its Lunar Reconnaissance Orbiter, so we can expect more photos and details to emerge in the coming days. But what is really interesting about this event is what it can teach us about lunar impact events and the hazards of artificial space debris. The European Southern Observatory's Very Large Telescope even detected spectral lines of sodium and lithium gas in the impact plume, which could provide valuable insights into the composition of the lunar soil and the rocket itself. As we continue to explore and utilize space, understanding the effects of collisions like this one will become increasingly important. And who knows, maybe one day we'll be able to use this knowledge to mitigate the risks of space debris and create a safer environment for human exploration and settlement. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat, folks. We're diving into the fascinating world of light and exploring the electromagnetic spectrum. You might be wondering, what is the electromagnetic spectrum? Simply put, it's the range of all possible frequencies of electromagnetic radiation, from low-frequency waves like radio waves to high-frequency waves like gamma rays. Now let's talk about the visible part of the spectrum, which is the light that our eyes can see. This includes colors like red, orange, yellow, green, blue, and violet. But what is interesting is that there's so much more to the electromagnetic spectrum than what we can see with our naked eye. For instance, infrared light has a lower frequency than visible light and is often associated with heat. On the other hand, ultraviolet light has a higher frequency than visible light and is responsible for giving us sunburns. Then there are X-rays and gamma rays, which have even higher frequencies and are used in medical imaging and astrophysics. Astronomers use different types of telescopes to study various parts of the electromagnetic spectrum. For example, radio telescopes can detect radio waves from distant galaxies, while space-based telescopes like Hubble and Webb can observe visible, ultraviolet, and infrared light. The ability to observe different wavelengths of light allows us to learn more about the universe and its many mysteries. By studying the electromagnetic spectrum, scientists can gain insights into the formation and evolution of stars, galaxies, and other celestial objects. So, the next time you gaze up at the stars, remember that there's a whole world of invisible light out there waiting to be explored and understood. Welcome back to Star Chat. As we conclude our journey through the cosmos today, let's take a moment to appreciate the sheer scale and complexity of the universe we inhabit. Our final destination is a fascinating region of the sky known as Rubin's cosmos field, a patch of celestial real estate that's several times larger than the full moon. Located in the southern hemisphere, this field has been observed by some of the most powerful telescopes in the world, including the Hubble and Webb space telescopes. The reason it's so appealing to astronomers is that it contains relatively few bright stars from our own galaxy, the Milky Way, offering an unimpeded view of other galaxies outside our cosmic neighborhood. As we gaze upon the central panel of this image from the NSFDOE Vera C. Rubin Observatory in Chile, we're met with a staggering sight: over 500,000 galaxies, each with its unique shape and size. The outer panels provide zoomed-in views of specific regions, highlighting the incredible diversity of these celestial bodies. Some of them are so distant that their light has traveled for billions of years to reach us, carrying secrets from the earliest moments of the universe. The Rubin Observatory will continue to monitor this field as part of its 10-year legacy survey of space and time, allowing us to witness the dynamic evolution of the cosmos in unprecedented detail. This will enable scientists to study the formation and growth of galaxies, the distribution of dark matter, and the properties of dark energy, which drives the accelerating expansion of the universe. As we reflect on the wonders of Rubin's cosmos field, let's remember that we're part of a much larger cosmic narrative. Our existence is tied to the evolution of the universe, from the emergence of the first atoms to the complex societies we built today. The study of the cosmos reminds us of our responsibility to care for our planet and to continue exploring the vast expanse of space that surrounds us. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.